Guys, that's something like y equals, 4x cubed minus 2x squared plus 7x minus 8. Like, those are polynomial functions. You have to have exponents that are whole numbers. Whole numbers are 0, 1, and 2, like continuing. So basically that means no negative exponents, no fractional exponents. Looking at our little polynomial up above, n is called your degree. You guys know what degree is, right? It's your highest exponent of your polynomial. We've already talked about that with n behavior, right? We are skipping the next one. A sub n, that's your leading coefficient. Again, review there, you guys know leading coefficient and degree. And then a sub 0 from up above, that's just your constant. That's the number that doesn't have a variable with it. Okay. So guys, go ahead and try to complete the table for me. For each of those polynomials, tell me the degree, the leading coefficient, and the constant. Rachel, were you on the field trip, or where were you? Where'd you guys go? Oh, okay. Was it interesting? Okay. Yeah, it is nice outside. And guys, also everything we're doing with Unit 7 here, all this homework, this will go on 4th quarter. Okay, so your grades are, I mean, they're not fully updated in SIS. I haven't put in your quiz grade adjustment or obviously your retake, but most of your grades are in. Yes. And you'll have probably 2 more next week. Or another one Friday, and I see you guys 3 more times before the quarter's up, and you're going to take 2 more trig quizzes, so. So be ready. Okay, apparently I can't take it till next week. Yeah, you got to think about your quadrants, and that's not easy. All right, let's see how you did. So first one there, degree of 7, leading coefficient 6, constant 10. Everybody okay with that one? Second one, degree of 3, leading coefficient 1, constant 0. Does that make sense? It does have a constant, it's just a 0. Because I could write x cubed plus 0, right? Okay. Yes. Yep. All right, guys, the third one, that's just the 12. This is kind of the weird one. You could rewrite that as 12x to the 0 if you wanted to. So the degree of that function or polynomial is 0. Your leading coefficient's 12. Your constant is also 12. That one's a little strange. And then the fourth one, the only tricky part with that is it's not written in the right order. Okay, so your degree is actually 8, and your leading coefficient is 1. Constant's -4. Did anybody get tricked by that one? Or okay? Yeah, you see it now though. All right, any questions on those? Okay, so the next little section here, decide whether these are polynomials or not. So, if it is, write it in standard form, status, degree, and leading coefficient. So I want you to try those. The only things we've talked about that make it a polynomial really are the exponents. So look at it, see if you think they are polynomials or not. Okay, I'll give you a minute. Let's look at the first one together. What do you guys think about that one? Yes. All right, yes, and then squeeze it in there, writing it in standard form. Negative 3x to the fourth plus 1/2 x squared minus 7. That's your degrees for leading coefficient, negative 3. Okay with that?
Can you write it in standard form? You just kind of switch it out so it's like everything higher.
Yeah, order of exponents, like biggest to smallest. Yep. Just be careful. I mean, the only thing you can mess up there really is your signs. Like, take the right sign with it if it's positive.
What's the degree that she's got?
What exponent's there, even though you can see it?
It's only 0 for whole numbers.
Mm-hmm. Yep. Have you guys done B and C yet, or do you need a minute? I don't know what. Okay. Just here grunting today. All right, guys. So letter B. That is also a yes. I know we're throwing some other things in there with the pi and the root 2, but your exponents are still nice whole numbers. So that one, the standard form would be pi x squared minus 0.05x minus root 2. So your degree is 2, and your leading coefficient would be pi. Did you guys get that one right? Yes, okay. And then the last one is a no. Why is it a no? Negative 1. Okay, good. All right, we have some important features of our polynomial functions. They will always be smooth and continuous. So like an absolute value graph, that's not a polynomial, okay, because you've got a point on it. If you have any type of discontinuity, any hole, any asymptote, anything like that, that is not a polynomial. All right, they have at most n minus 1 turning points. N minus 1, that just means your degree minus 1. You guys remember this from Algebra 2? So for that first example there, what do you think? It has at most how many terms? 2. Yeah. What about it, the second example? Okay, easy. All right, so far so good. A function of degree n has at most how many x-intercepts? What? Close. It's just n. Okay, so whatever the degree is, like if it's x to the fourth, then you could have 4 potential x-intercepts. You might have fewer than that. You might have double roots. You might have imaginary roots, all of those things. But at most you would have whatever the degree is. And then at any x-intercept, we call that a 0 because that's your y value if you're on the x-axis. Okay. Your y-intercept, you find that by plugging a 0 in for x. It's always going to be your constant term. Sometimes your polynomials will be in standard form, sometimes they'll be in factored form, so you may have to plug in your 0 to find your y-intercept. And then your end behavior, that is a review from last unit. So if you need to jot that down again, it's even and positive, both ends are going up, even degree, negative degree coefficient, both are going down. Odd degree positive, odd degree negative. You guys remember that from last unit? All right, guys, so questions so far? Are we still alive? We look like we're dying a little today. Are you going to make it? Okay. All right, so let me draw another box. So over to the right side of your page. All right, a couple things here. If f is a polynomial function and r is a real number, then r is a 0. 2 things we know about it. If it's a 0, we know it's an x-intercept. And then we also know we have a factor. So guys, if I tell you you have a 0 of, or your zeros are like 4 and negative 2, could you tell me your factors using those zeros? Yeah, x minus 4 and x plus 2. Does that make sense? Okay. That's all that's talking about. Okay. All right, and then we're going to get into multiplicity here. So if the same factor occurs more than once, then you have multiple or repeating zeros. And you can have even or odd multiplicity. I'll show you those in a minute. An even multiplicity creates a point of tangency. You may have been told it bounces off the x-axis. Does that sound familiar? Okay, and then odd multiplicity will give you a point of inflection. It kind of looks like a cubed graph when it goes through the x-axis. We'll draw them here. What we're eventually going to do with all of this information, guys, is actually sketch polynomial graphs without a calculator. Okay. Rather than trying to squeeze it in, I'm going to just show you what I mean. So let's say we had x minus 2 cubed times x plus 5 squared. You guys understand it would cross the x-axis at -5 and at 2? Okay. End behavior, do you guys see how this would be a 5th degree function overall if we multiplied it out? And it's positive, right? So I know this end would be going up and this end would be going down. Okay. At -5, you guys see how we have even multiplicity up here with the degree of 2? That means it's going to bounce off the x-axis, so it's going to touch it and then come back down. And then at 2, with odd multiplicity, when it crosses, it looks like a cube crossing. Okay, it doesn't just cross straight through the x-axis. That's what we're talking about when we talk about multiplicity with our zeros. Okay, we're going to do a bunch of these, so don't worry if you didn't get this one copied down. Okay. All right, so first let's do this example here. Find a polynomial of degree 3 whose zeros are -3, 2, and 5. So first, just write it in factored form for me. All right, guys, and then I want you to try to multiply it out. So was everybody there? Y equals x plus 3 times x minus 2 times x minus 5? Okay, start multiplying. How we doing, guys? When you're ready, look up here, see if you got the right thing. Hush. Get it? I didn't know. Got it. Okay, guys. Anybody questions on the multiplying, the algebra going on there? Bobby, you good? Okay. All right, so that's not too bad, right? Eventually we'll get into ones where I'm asking you to multiply it out when you have imaginary roots too. But not right now. Alright, so I am changing this problem. Well, I'm just changing your directions for you. Let's go through this one together. So you guys see on part B how it says to use a graphing utility? That is not happening. You don't need a calculator to graph this, okay? Just move the rest of this down. You don't need one at all. But we are also not going to do that part. So let's look at the first part. Alright, so I've got f of x equals x cubed minus 2x. Would you agree that is the same as x times x squared minus 2? Everybody okay with that? Okay. So if I wanted to find the x-intercepts, that means I'm setting this equation equal to 0. And what do I get for my x values? I'm looking at x equals 0, right? And then if I'm solving x squared minus 2 equals 0, what do I get? Plus or minus root 2. So these 3 points, these are your x-intercepts. Okay? So let's make a little sketch here. So I've got okay, so if I'm plotting my points here, I know I cross the x-axis at 0. And then positive and negative root 2. Okay, I told you don't have a calculator. How do you figure out where root 2 is? Let's think about, oh, go ahead, Bobby. A little bit more than 1, right? Yeah, it's going to be in between 1 and 2, right? Because it's in between the square root of 1 and the square root of 4. Okay, so yeah, and I do not expect perfection with where the square root of 2 is located. Just put it somewhere in between 1 and 2, and that's fine. So I have a positive 1, and I have a negative 1, okay? Looking at my graph, do we already know our y-intercept also? What is our y-intercept? 0, yeah, so your y-intercept is also going to be 0. Then let's think about our end behavior. So you can go back to the original one if you want to. Degree was 3, right? And it's positive, so what are my ends doing? Yes, okay, pointed the same way. So this one's going up, this one's going down. And did I have multiplicity with any of those 3 zeros? No, you did not. So it's just going to cross the x-axis, cross the x-axis, cross the x-axis. Now, are you going to know exactly how high this little relative max or how low this relative min go? No, I'm not going to make you find those by hand. I just want the general shape of the sketch. Okay?
Wait, how do you find multiplicity?
So it would look like if you had
That's what it would look like if you're going to have a multiplicity.
well, once you factor it, do you see how there's this exponent on the factor?
Yeah.
That's multiplicity.
Okay.
If you just have like x plus 2 times x minus 3, yeah.
Okay.
Okay, so like none of those would have multiplicity. I could add like that out front, that would have multiplicity.
Okay.
Okay?
Okay.
All right, so are we okay with that first one? Okay, let's try. Maybe. Okay. Let's go through the scale together. All right, so we have x to the 4th minus 3x cubed minus 4x squared, and I want you to sketch it find the x and y intercepts. And then you can tell me the number of turning points, all that good stuff. So let's start over here by factoring this. What can I factor out of x to the 4th minus 3x cubed minus 4x squared? X squared, good. So then I'm left with x squared minus 3x minus 4. So what does that factor into? Okay. X minus 4x plus 1. All right, so sketch. Okay, what are my x-intercepts? Let's start there. Where does it cross the x-axis? 0. Good. 0, 4, and negative 1. So my x-intercepts, 0, 4, and negative 1. Which one of those has multiplicity? 0, and is it even or odd? Even, okay. So we'll squeeze that in next to the 0. All right. Y-intercept, we already see that on our graph, right? Also 0. Could you list these as ordered pairs instead of just like this? Okay, so your y-intercept would be 0, 0. This would be 0, 0, 4, 0, negative 1, 0. Okay. All right, so let's make the sketch then. Go back to the original. It's even degree, positive. Where are your ends going? Both are going up. Okay. All right. And where is something interesting happening? At 0, right? That's where it's going to bounce. So this is going to kind of look like a weird W. Okay. We okay with that? Turning points, that I always want you to tell me it should say possible number of turning points. That's always just your degree minus 1. So in this case, that would be 3. Okay. Oh, and let's fill in your end behavior too. I left that out. You already drew it on your graph, but you can write it for me too. Okay there? Questions so far? Okay, we are skipping number 2 that's in your packet because I'm not going to make you try to factor that. It does not look like fun. Let's do some whiteboard practice. Yes, sketch the graph of that. There's 3. Oh man, and they all have multiplicities. Holy cow! I think you can do it.
No, I don't believe that.
Yeah, that makes sense. Wait, like not to read in that. She's so cute. I wish I was. I think my sister should. Hey, you're different. My sister was different.
It's just,
Hold on. Counting. Did you just say whatever to me?
This is supposed to be.
Okay, then yes. I like your ends, but I don't like what's going on in the middle. Okay. No. So guys, the degree would come from multiplying it all out, right? So that'd be like x squared times x cubed. So you don't have to multiply this completely out. Just think about what your biggest exponent within each piece would be doing. So like you'd have x squared, and then it'd be times another x squared, and then times another x cubed. So the degree is actually 7. You'd obviously have a lot of other stuff if you multiplied it out, but that would be your first term. Does that make sense to you or not? Yeah. Okay.
So what's the degree of it?
It's factored, yeah, so you've got to add them all up. Yes. How are we doing, guys? I feel like some of you have stalled out on me. David, did you do it? Okay. Starting off Unit 7 strong. You've got one in your desk. We can see it. No, forward, forward, forward. Like, there's a green one, like that's right there. No, keep. There you go. All right, guys, let me show you this one, and then, so David, you can do the next one, okay? All right, guys, do you understand that one? You've got a point of inflection. So Megan, the ends, if you think about that, if the degree is 7, that's odd. They've got to be going in opposite directions, right? Yes. Yeah, so it's sort of like a cubed graph. Yeah, that's what a point of inflection is. And then we bounce at 0 and we bounce at 3.
A bounce comes to 0.
Are we okay with this one? Anybody have questions? Should we try again?
Oh, wait.
And guys, I want you to find your y-intercept on this one too. You don't have to have like the right number of tick marks for it, but you should always label your y-intercept. All the ones we've done up to this point, you went through 0, 0, so your y-intercept was easy. This one, you gotta do a little more work. So grab some water. What? No? Forgot what I even gave you, sorry. Yes, and ooh, let me see your, okay. Yeah. Okay, but yeah, I was like, what? And then I see it up above, so. Yeah, I think I'm reading your y-intercept right. Did you find your y-intercept? Yes, thank you.
Yeah, that makes sense. Oh. That makes sense. That one doesn't come. Yes.
Right, so if you do minus 1, then you also have 1 times
Okay. Oh, you can fly all. Okay. Okay.
How we doing, guys? I haven't changed it yet. All right, guys, let's look at this one, see how we did. So you have a lot of things going on here. You have a negative out in front. Your degree ends up being 5, so your ends are going the opposite way. You've got your 3x intercepts. 2 of them are going to bounce. What did you guys find your y-intercept to be? Negative 18, and how'd you guys find that? Plug 0 in. Yeah, that's all you gotta do. Plug 0 in. Okay? So that is what your graph should have looked like. Okay, all right with that? Are we getting a little bit better at it? Yes, okay. No, I heard a no over there. Let's try again. Okay, guys. You have to factor this one before you can graph it, okay? So take a second here, factor it, and then do exactly what you've been doing on the other ones.
That page.
So you did it for both?
Yeah.
Oh, thank you.
Yeah. Just they would just when they would they would start like doing the next triangle, or if they filled it out, like if they filled it all out, I took off 2 points, or like if they started with 1, I'd take off like 1 point. I don't know. Since you told me to take off 1 for that one,
Yeah, like,
and then there's another one where I was like, okay, I can't just take off 1 point.
yeah, if they did, like, if they filled in all 3, I would have taken off 3.
Oh, I only took off 2. Yeah, because it was.
Hopefully it wasn't a lot.
No, well, it was like they actually people just like I don't know. People are just weird. Like actually, like -10, -5, like -18. Like there were not a lot of good.
That's here. It's either A or D's.
Yeah.
Like there was not a lot of middle of the road overall.
Wait, what about 7th grade?
That's what I mean. They're the only ones I've totaled up. It's
Did
like
I just
there's
grade
good A's.
theirs? No, I graded all.
It's fine. Simi will be happy. Yeah, so she. Yeah. 70. But Emma did good. Like a 90.
Stock market.
Yeah, see, so he wants to change graph of volume.
Rachel, you don't think in your daily life you're just gonna walk around graphing polynomials all day? Come on.
You're gonna have a pretty boring life then.
Yeah, this specific skill you will not use, but you have to like get through the steps to get to. You got 10 minutes. You could.
I mean, in this, yeah.
All right, guys. Is that where we got to? We were okay with the factoring? It bounced at 0? Okay. I'm going to give you one more. Looking at your packet, your homework did not copy correctly, so I have to fix that for you. So, if you factor this, you would take out an x squared, right? And then you're okay with that, right?
Uh-huh.
Okay. See how that has multiplicity? That means it has to bounce when you get to 0. So I know both ends are going up. So when it crosses, I know it's coming from down here. It's got to just touch it and come. Does that make sense?
Yeah.
You sort of have to start from the ends and work your way in and see whether it bounces above or bounces below.
Yeah.
I don't want to give you that one. I'm making up a one. Maybe. All right. Okay. So let me go fix your homework on the copier, and I will be right back. Maybe.
Whoa. That always amazes me, man. Always amazing. Wait, how do you get this? That's how. All right.
Right, so
Dude, I couldn't.
a negative, no, negative.
Yeah.
If it's positive, oh, yeah, really.
Like, I just laugh at how it works. What?
All good because it has to bounce back on this one.
Look at how we're being.
What? How did you get this? I'm trying to explain what's It's not. Okay. That's even a bigger number. What is it?
Alright guys, how are we doing?
47 times 96.
Let's see. The y-intercept is pretty big, yeah. Is that 6 times 27? Yes, let's go through it, guys. This is your last one, then I'll hand you your homework. It's really 100. You've got a weird scale going on your y-axis. That's okay. All right, guys. So it's going to cross at 3, at 6, and -1/2. Everybody's okay with that, right? And your ends, everyone has them both going up? Yes? All right, it bounces at -1/2, right? Bounces. And then this is a lovely, ooh, that's terrible.
I say what?
You do say 1.
Yeah, do not say what. Should I never say what? Like if you're like doing something and you're like, what?
Felipe, you would not get along with her at all. All right, guys, are you okay with your y-intercept on that one? Okay, your homework is your packet, so I just recopied it for you. It, like, the first page got copied twice, and you were missing the last piece, so.
Oh my god.
He does do that. The first part.
Dude, I cannot stand that. I can't stand it. It bugs me so bad.
Does anyone have money that they would like to donate?
Yeah.
If not, bring stuff. Yes.
Guys, we're in 3rd place, but we will sneak up on everyone, okay? I will be bringing a lot in on Friday as well, okay? So please bring stuff. Simple enough, right? Do I have a Remind 101 for you guys yet or not? Yeah. Like, I think I made one at the beginning of the year, right? Yeah, okay. I will try to remind you, okay? I have them right here. I just don't have them recorded.
But this way, I can take the package homework to
Yes.
finish every single long
Guys, do you want me to say your grades out loud? Do you want? I don't have them all recorded yet, so I will say your name and you can say yay or nay.
Yeah.
David. You want me to say it? Somebody know. Felipe.
I'm going right.
Yeah. Xander.
So no one else is donating to that?
Anybody else? Money? Bring stuff? You had trouble with number 5.
Yeah, I did.
Yeah.
Yeah,
Well, remember doesn't hurt you guys, Bobby.
Oh no.
Steven.
How?
Well, now is not the time for the house. Maggie. Allison, I think I see you. Emma, you're good. Oh, you're good. Rachel. Yours was good. Giselle.
I did good? Oh wait, then I'll see it. I just don't want to be disappointed.
Really? Yeah.
That was good.
Yours is not graded.
Like that,
Two
you
seconds turn around.
Hey, I did better on this than I like did on the last one.
Yeah, triangle's kind of hilly.
Can I look at mine too? Just
Ron was like, I need it now.
Yeah, it's like,
Oh, Ron, look, you can look at it right now. Doesn't matter at all.
No, it's not.
Yeah. There's one that has
I think it might be. Okay.
How did I do on the triangle part?
I think fine. No, because people are still waiting. Sorry.
Oh, what? Like, exactly.
So, like, I feel like it was just a lot of, it wasn't like one thing. Hey, thank you.
I didn't find that hard at all.
You did an 80. Let's see it. I think you were great until the very last page. If you had issues, there was one that was a 2 triangle and you didn't have.
But that didn't work. I tried to do that. Because I knew it was supposed to be 2, like.
You must have messed up the first one. Like something must have. Yeah. Okay. Alright.
But how did I do on the not triangle part then?
Better than you did on the triangle part.
Also, so in terms of that one quiz that you didn't, like you said, just let this be the makeup.
So your test is the makeup for that. So whatever you got on your test for that unit, that's what goes in there. And then it's like the quiz grade adjustment just happens, is what it is. But your quizzes do not get adjusted again by your test. Okay? Because that's just too many times. It's basically like the test is the retake on your quiz, and then the quarter test is the retake on your test, and then we're done retaking.
So if I did well on that test, then the quiz that I missed either is gone. Well,
Yeah, it'll be whatever that grade was. Okay.
I don't. Is it in yet, or?
I've updated some. I haven't gotten to all of them, so I really don't know if yours was one I got to or not.
Anyway, I'll see you next week. Because I'm not be here. So.
Oh, you won't be here Friday? Okay.
Yeah.
Oh, you're on the orchestra thing?
Choir.
Oh, choir's gone too. And you guys are just like going to Florida? I mean, you're just like.
Well, we're going to Orlando. There's like a Disney thing where we'll like we'll sing and there's a lot of places to prove.
But it's not like a competition. It's just like a for fun thing.
Yeah.
Why did they go? Why did they pick this time of year to go? I mean, I know it's obviously not your fault. It's just interesting.
I think.
Uh-oh. I blame Will.
Thank you.
See ya.